Which of the following presents with hyperkalemia, hyponatremia, and hypercalcemia? So before going through the answer choices, let's review RAS system, right? So RAS system is actually only aldosterone is important here. So its end product is aldosterone, and what aldosterone does, it acts on the kidney, in particular to the collecting duct on intact channels, and it reabsorbs sodium and water, right, and increases circulatory value. So what it does to electrolytes and pH, right? So Melman in his Eros PDF have great mnemonic, I think, it that aldosterone increases everything beside potassium. So if there's increased aldosterone, you have decreased potassium, and everything else will go up. What about calcium? It's actually have mineralocorticoid receptor on parathormone. So if it's activated, it increases parathormone secretion, and by doing that increases calcium. So if there's increased aldosterone, there's increased calcium as well. So let's look at the answer choices. Barter syndrome. So Barter syndrome acts like furosemide, right? It's inactivating inhibition of sodium potassium chloride sympater on the thick ascending limb of Henle. So by inhibiting that, you lose sodium and water, so it acts like diuretic, right? And I want to tell you about Gentleman syndrome as well, because it acts like thiazide, and we always compare thiazide and furosemide, right? So what it does, it inhibitory mutation, like acts like thiazide, right? So it inhibits the sodium chloride sympater. You lose sodium, you lose water, okay? But how you distinguish furosemide from thiazide or Barter from Gentleman? By looking at this calcium. So furosemide or Barter syndrome is losing calcium by urine, so you will have hypocalcemia in this case, whereas thiazide or Gentleman syndrome saves calcium, so you will have hypercalcemia in this case. But all these diuretics, including acetazolamide, which acts on the proximal convoluted tubule, right? So acetazolamide, proximal convoluted tubule, loop diuretic furosemide on the loop of Henle, and thiazide on distal convoluted tubule. All of these diuretic decrease potassium levels. So therefore we have a separated group of diuretic, which is potassium sparing diuretic, like spironolactone, aldosterone antagonism, right, and eplerenone intact channels inhibitor, or amiloride, right? So by knowing that, let's look to the Barter syndrome. Barter syndrome decreases potassium levels, so hyperkalemia in this case is not the right answer choice. So Barter goes away. And Little syndrome. Little syndrome is actually activating mutation of intact channels on the collecting duct. So what it does is acts like there's a lot of aldosterone, right? So it makes pseudo hyperaldosteronism, because it decreases potassium, increases everything else. But when you look at the aldosterone levels, there's actually decreased aldosterone, because by activating intact channels, constantly activating it, you increase your blood circulation, right, value, and therefore shut down the RAS system. So therefore, there's decreased aldosterone, but all of these electrolyte changes present, right? So what we have in Little syndrome, we have decreased potassium, and therefore aldosterone, and therefore the Little syndrome goes away as well. What about Addison disease? Addison disease is the right answer here, because Addison disease is primary adrenal insufficiency, where you lose cortisol and aldosterone as well. So when there's no aldosterone, you increase your potassium. We know that, right? What about calcium? Why it increased then? It's because of cortisol. First of all, because cortisol actually inhibits vitamin D activation. So when you don't have cortisol, you don't have this inhibition, and therefore there's increased levels of active vitamin D flows around and increases calcium absorption by your bowel, right? So therefore, in Addison disease, we have increased calcium levels and increased potassium levels. So, and second mechanism of calcium, increased calcium, is that you don't have enough volume because you lose it because you don't have aldosterone, right? And you don't have enough pressure because you cannot maintain blood pressure because you don't have enough cortisol, right? So you don't have enough filtration in your glomeruli to filter out calcium, and therefore calcium is also increases. What about spironolactone? Spironolactone is actually inhibits the synaptic channels, right, in collecting DAC, and it inhibits aldosterone receptors. So you have opposite reaction to aldosterone by increasing potassium and decreasing everything else, right, including calcium. Calcium can be low or normal here. Fankoni syndrome is actually damage of our proximal convoluted tubule, where most of the reabsorption of electrolytes proteins is going on. So when you damage this proximal convoluted tubule, you lose everything, right? Potassium and calcium will go down in this case. So Fankoni syndrome is wrong answer here as well. Our answer here is Addison disease.